Hi, my name is Abdul Dakkak. I'm a PhD student at the University of Illinois at Urbana-Champaign. We're part of the IBM AI Horizons Network, and the center is called C3SR, or the Center for Cognitive Computing for System Research. And this is joint work between me, Andy Xu, Jinzhen Xiong from IBM, and Wamehu. So the objective of this talk, or this tool that I'm presenting, is that one thing that we were having trouble with when power systems were first introduced is there was a lack of kind of an ecosystem for containers and sort of ability to compile stuff on these systems. So we were, the kind of backstory is that we were teaching a GPU programming class using Power 8 systems 2 years ago. And one of the things that these students had to do was develop an open-ended project. So they bring in their own project and develop it on these P8 systems. And the P8 systems were, the state of the art back then. We were developing in a thing called Rye, which we developed in-house. And what Rye allows you to do is develop locally on your system, but execute all the code remotely. So you can think of it as a lightweight. It's a bit more powerful than SSH in that a user is oblivious to the which system is actually executing the code. And it has the same benefits as SSH. But we found a limitation in the Power ecosystem. So these users were trying to execute code, and they relied on some libraries. And the code they executed, the libraries, the easiest way to put them on these Power systems was to use containers. And we found there's not that many containers on these Power systems. We're trying to do cross-compilation, so x86 cross-compile on Power, using tools like QEMU or just installing the kind of cross-compilers. We find those to be either slow or it just didn't work. And if you look at the current ecosystem, this is just a rough idea, in terms of Docker containers. On Intel, there's about 2 million, Docker images on Docker Hub. For ARM, there's about 8,000, and for Power, there's about 500. This is again a rough estimate. And using our tool, we contributed to 300 of those 500 containers, so just over 600. 60% of the containers we're responsible for. So what we were trying to do was extend the PowerPC Docker ecosystem by making it possible for people to build on Power without really having access to the hardware. So people are interested in making sure like TensorFlow or MXNet compiles on Power, but an open source developer does not have access to the Power system. So any kind of person off the street can then just develop these or compile and run on these Power systems. We also wanted a way for or a home for these Docker containers so that people don't have to sift through Docker Hub to find them, because it's somewhat hard to search for architecture-specific containers on Docker Hub. So let me show you a demo of this, and this is a tool that we've been using for quite a while. And it has this is the web interface, and I'll show the command line interface in a little bit. So again, it's a bare bones system, but the idea is that you have a drop down, and what you're able to do is, let's say, I upload like a zip file, and you now have an editor. and you can have multiple files that you're editing. But this is a Docker container, and then I can say, okay, I want to build this. And this is going to build on some machine in the background. So this is either running, we have a power system at Illinois, and we have one that was donated by IBM in their servers farm, and there's another one in Oregon State that we're using. But this built the containers, the container, because one thing that the reason it's actually built it quickly is because these things are cached. But let's say I modify this CUDA version to be 10. Now it's going to have to build, it's now downloading some apt install packages, and this is actually real time what the server is doing. So it's downloading some packages. So let me actually go back to and show, for example, how you'd be able to. So let's say I've built the image, and now I want to publish it to Docker Hub. So what I could do is, I built, I just test if it builds. Okay, it builds. And now I can essentially say, okay, I want to publish it to Docker Hub. So let's test latest. I think that's my username. So now it's actually built the image, and if I go, and it's going to publish. So it's publishing the Docker images, and let me go to hub.docker.com. I think it's, oops. So this is the image that I published. So this was a test from 5 hours ago, but in a few seconds, it will be published, that test case will be published. Let's just, any question, by the way, you can feel free to ask any questions at any time.
So do you maintain those images up to date, or this is a single shot? So we ported, this is the image used by your own, and if you have any issues, go fix it. So how do you handle that?
Right. So actually, let me, so while we're waiting for that. So we have so IBM actually, and we developed a bunch of Docker images. I think it's on GitHub, there's a repo called ppc64le/build scripts. So we actually build those regularly. So IBM maintains them, and we also, do a bunch of, we have our own images. So in that terms, we build regularly for them. So these are the images that, we have. And if you actually go to the, one of these links is this is the Docker file that it's based off of. So, this was updated last August, and you can see, the Docker Hub image that was built. I don't think I clicked on the same thing, but, this is the, IBM COM cookies, ppc64le. And we have, 300, as I said, of those, 306 of these images that we maintain. Now, if there's a new version, it's up to the person who's developing the Docker file to make sure that they've updated the scripts and things like that, and they can use these tools to actually push these changes. Yeah.
So just to show that you pushed a test image, if you updated, does this work better? If you updated the image, could you actually set your version tags to show that, so you get multiple versions out there, which is a piece of the currency question that Raphael's
so
asking, right? But it's not the whole story, but it's a piece.
So when you publish the image, you can just say, so let's do this again, test, v2 or something, push. So actually now I have this, I should have latest was updated 2 minutes ago, but I should have, once this v2 thing finishes, I will have another tag that's called v2. So yeah, so you can actually have a version, using these git tags or git args and stuff like that. Yeah.
So first question, so do you sign those images? So one of the concerns about using images that are provided by other person or other company is regarding the content of those images. So first question, do you sign those images to ensure that the source of the images is some trust authority, something like that? So
no, we don't. One thing is all of this is also open source, so you can actually, and the server is also open source, so you can bring up your own one of these and do modifications.
Yeah. Second question. So today, Docker or container is just part of a Kubernetes ecosystem. And as part of the Kubernetes deployment, like OpenShift, for instance, I can create a Helm chart, which is, you can see that as a package for deploying your application inside the Kubernetes cluster. So somehow, can I attach this process as part of my Helm chart creation process? So when I'm doing a deployment on a Kubernetes cluster, for instance, I can somehow create an image that was originally created for x86, port that image to Power, and do the deployment inside my cluster, kind of. Can I have this attached to a CI/CD system? Do you have API for that? Do you have anything that can attach? I can attach to your system to do some other automation behind the scenes?
Right. So there's a few ways. One is, I'll come to there's a command line version of all of this. There's also you can use the REST API if you want to use that, or there's also an RPC API that you could use. So, depending on what sort of level you want, you could interact with this. You don't have to do a bunch of clicks to do these. And actually, I'll show in a few slides how we integrate that with a continuous integration system, which it just provides machines for x86, but we use those to build Docker, Power Docker images and run those as well. Yeah.
Had to wait for the mic, sorry. So to answer part of Raphael's question about the security as well, and I think you know this as well, the IBM Com directory space up there on Docker Hub, the only people that can write there are select sets of IBMers or those that have been given a proxy, right? So there is some security built in there because of who has the keys to go publish, right? So now it's up to their publishing system, but the Docker Hub or the sign-in that they use to get to Docker Hub is very unique to them. So that is some help, and the rest is Docker Hub protections. The other question that I think Raphael asked, you answered part of it really well, but anything about Helm charts or OpenShift, a lot of that's going to go into like a Red Hat repository rather than yours. The Docker Hub is where it's still going to pull all of the containers from, but all the auxiliary operators, Helm charts, et cetera, are going to come from currently a Red Hat OpenShift repository.
Right. So actually, let's go back to this thing. So now, so going back to this different tag, now you see this v2 tag that was published, 4 minutes ago. right? So we maintain not only like this sort of interface where, you know, kind of any person with a web browser can just go in and build Docker images so that, you know, the cost of entry is low. But we also have this list of power images. These are, you know, one thing about this IBM COM is it mixes, there's power architectures, there's also x86, and there's Z. There might be others, I don't know. So we actually just differentiate with, you know, we built the power and Z architectures, and for this case, we're just concentrating on the power kind of images. So a bunch of this stuff is I already answered, but you know, in terms of the website, we support multi-file editing. So one of the issues is, you know, Docker files sometimes have attachments or other scripts that need to be used. So users can upload text files or zip files, you know, and then the other thing is that when you get the output, it's real-time streamed from whatever server is in the background that's processing. So essentially everything is in real time. There's also a command line option, so if you don't like clicks and things like that, so the command line option allows you to download a binary and you could essentially run a command that does the same operation. So let me, and it has the same interface as before, so let me zoom in. So, you know, this Docker file builder, you can download it online. And what you could do is say build, and this is essentially doing the same thing, it's just from a terminal, using the same image and the same terminal. And you can also upload these images. I think you need to upload, and you know, you put in your username and password for those. But the username, one of the problems is the password, you know, it's kind of plain text. So what you could do is you can create a configuration file that has an encrypted version of the password, or, you know. The other thing is it supports multiple architectures. So, you know, if I have these Docker for Power, I could, you know, there's multiple, as I'll tell you about the architecture, you can essentially change the queue, or, you know, where you're going to publish, and it will build for different architectures. Now you have to modify the Docker file so that, you know, you cannot build a ARM Docker file on a Power, but you can with the same command line, you know, say, okay, I'm going to run in parallel, you know, 3 different Docker builds on different machines. There's another thing which we support, which is the ability to execute. So you can, you know, you can kind of go beyond this. So once you've built the Docker container, you can execute commands within it. So one thing that we use this for is, for example, running benchmarks. So we want to have the ability to, whenever we make modifications to some library code, to, you know, build the Docker container and then run some benchmarks within that, and, you know, create kind of plots and things like that. And that's a kind of an extension of this work, which is we call RAI, and you can kind of find information about that in this GitHub repo. That's what we use for teaching and kind of as infrastructure in our center. Now, one problem with this is there's a lot of kind of continuous integration systems that would, you know, you'd like to use because they're tied into you know, tools like GitHub and things like that. So one example of this is Travis. So Travis is a simple tool that allows you to you know, you can use to build Docker images for x86, but we also want to build for Power. So we actually have a sample repository that essentially what it does is within Travis, it downloads this Docker for Power binary and uses a command line to build the images. And that example is in a tool we call Scope. which is a benchmark suite. And that's kind of the mechanism that benchmark suite builds these power images that people can use. So in terms of architecture, what's happening behind the scenes, what we have is, at our center, what we've done is we've built essentially a runtime for distributed kind of services. And this is just a manifestation of that sort of components. So what we have is at the top level is a web UI that's interacting with kind of an RPC or gRPC gateway. And that's using a set of components like, health monitoring, tracing, and things like that. And then in the background, there's some hardware that is running on. So when you actually do use for example, the web page, what you're actually interacting with is a web server that's essentially executing this Docker for Power binary, and that interacts with a set of worker nodes, and the worker nodes are responsible to publish stuff to Docker Hub. And you can actually have multiple of these suites of kind of worker nodes, and we classify them based on the queue. So you can essentially have a user can submit a job to the Power queue, and there's a bunch of Power nodes that are listening to them. So as I said, we have, for this sort of Docker for Power, we have 3 systems that are in 3 different states, essentially. But we also have other ones like, there's one for the Z system that's running I think in Canada or something, and x86, and there's also ARM and other sort of architectures. And the idea is that, a user can just say, okay, I have 5 images or 4 Docker images, and I'm just going to run them and compile them in parallel on all these different systems. In terms of resources, all of this code is open source, so you can find it online at Docker File Builder. And there's instructions on how you can essentially set up your own backend. So those are available at this RAID project/RAID. And it works. We've tested it. It works for x86, ARM, and Power, and this Z system S390X. And all of the hardware was provided by IBM and Oregon State. So we run on those. So with that, if there's any questions, I can. Yep.
Do you track usage through the system at all? And how much of it is not from you or from IBM so far?
What do you mean it's not from me, from IBM?
So other people that are using your Docker for Power front end, are there any others that are using it today? Is it well advertised? Is it well known?
Right, so it's not well advertised. That's the objective of this. And it's also not well known. There are a few people at IBM that are using it. In terms of development efforts, it's entirely from us. Although the people for Z, they have contributed some stuff to patches and things like that to run it on Z.
So Abdul, is it a purpose that you've got in a closed environment? I don't need that, man. Okay, for the record. Is it a purpose that you're not well used, not well known? Can we enhance your position by evangelizing?
Yeah, I mean, it's not like a position that I wanted.
I didn't know if you wanted people to come.
Yeah, definitely.
Okay.
Yeah.
Because we can do that.
Right. Yeah. It's not purpose. It's just Right. Yeah. The other thing is, yeah, and this is actually running on IBM Cloud, the web server. It's the Bluemix.
I mean, these services of the front end should be there an option there. You
Right,
log in
yeah.
in your account, let's migrate my container for Power. Then see all this stuff.
Yeah. Yeah, definitely. I'm very open to people, using it. In terms of like tracking usage, I think it's like there's Google Analytics. I think I can bring up. It's not very well. It's not used by a lot of people.
And do you think you have enough capacity that if people piled on, you'd be able to run through? Or are you short on capacity at the moment?
So the backend is elastic. So you could essentially, that's kind of one of the designs is that you can expand and contract it based on usage. We have 3 systems that are running, and I think that building these Docker images is CPU bound. It's as fast as you can compile, and we can have a control on the queue so that control on the queue so that only one compilation is happening at the same time, or you can oversubscribe these to get some progress. I don't think right now we're maxing out their capacity, but probably if you have like every person that's using Bluemix is also using this, then 3 servers might not be enough.
Yeah, and the reason I ask is, number one, we would love to see more people using this. Anybody that's trying to build containers that needs a way to do it, drag and drop your Docker file, your zip file, whatever over there. If you run out of capacity, ask me. We're going to put this on IBM Cloud at some point and have the background for it as well. So,
Right.
And I don't know, I've been kind of sitting here incognito, but I'm Garrett Heisinger, so Priya Seth that works with you works for me.
Okay.
So a lot of the jobs that you've generated are things that we've ported to Power from our team. But this to us has been a phenomenal service. The guys here at UIUC, I want to do a big shout out. Great job with this. Very simple interface. If you want to build containers and you don't have the capacity, you don't have the infrastructure, build your Docker file, drag it in, get it published.
I'll add here, I'm Terry. We've been emailing. So, Abdul, the reason I was asking is kind of his words there. I cover all the United States universities with all the sellers. Garrett has links to all the markets. If you want to open up your world to all of our ecosystem of people, we can orchestrate that in short order. I'll be on your campus September 9th, probably when Jinjun comes. Maybe we can talk about that with Vlad, but we need to spread the word.
Right.
Right? And so we can orchestrate a cross-industry, cross-functional, especially university WebEx.
Right. Yeah.
So talk to Vlad. Okay?
Yeah, I know one. The other thing that I think kind of going back to one of your questions is one thing that we were also, we haven't, it's relatively trivial is, for that build scripts Power PC thing, they constantly update these Docker files. Right now, what we do is, even though I don't like it, we manually, like every month or something, we look at the recent changes and we build those. But one thing that we are able to do, through some scripts is you can figure out which Docker file has been changed and automatically, build those sort of things and commit them to the Docker file. So you essentially can have, a thing like a hook or a webhook or something to make changes. Yeah, there's a question.
So you just triggered a thought for me that I hadn't put together. I also work on the Travis CI stuff. We could get a travis.yaml file and publish it for each of the build scripts if we had a way to connect it to go to your D4P container. We should talk offline, but there's probably a quote-unquote easy way to go automate some of this stuff, so it's doing some currency work.
Yeah, so what we have for that, one of our repos is whenever a git commit happens, we download this binary, Docker for Power binary. It creates some, configuration file, so it creates a new version tag, puts pushes the latest version, and then whatever the branch tag is, and then pushes those to Docker Hub. But it also, so that uses the power, but for x86, it just uses regular Travis. It doesn't do anything special. We plan on also writing a blog about all of, more of how you go about doing this. Not so much about architecture, more about the use scenarios. That's coming up in a few weeks, I guess.
So I can't shut up, can I? So when you get ready for that blog, copy me or Jinjun on it, and
Right.
we'll put it on our blog engine from IBM as well, on the developer portal.
Right.
So I've seen a couple of large directories on the Docker Hub. One of them is a IBM com that was already mentioned, and probably another one is a PPC64LE. Is that yours?
No, we have another one called C3SR, I believe. But we've been moving to this IBM com one as well. So we have another one called this C3SR, which is our center, and it also has a bunch of these PowerPC images. But we've been moving, so that's why these are 2 years old, because we've moved all these to the IBM com directory.
So to answer your question, the PPC64LE one is actually owned by Docker Hub, and it's one of their guys that does. He goes by Tianan, but he actually does all the official builds of Docker images for all architectures, and those are published automatically to PPC64LE. So that's a lockdown Docker-only repository. Right. So we publish to IBM com. We work with them to do so. That's kind of the official on that side.
Thank you.
Yeah, so I'll be around if you have any questions. And I think the lunch is next.
Thank you very much, and great discussion.